the left out one in this is energy of the projectile. I am going to do energy of projectile. Energy of projectile in this. So usually energy means in lower classes you might have studied kinetic energy and potential energy. Both the parts we will be doing. Okay. So when projectile moves upwards, so when it is in motion, what happens in motion? It will have kinetic energy. What happens when it is going upward? Kinetic energy decreases and potential energy increases. Why potential energy increases? Because the potential energy we will get due to height only. So as height is increasing, potential energy increases. So again, same thing, when it is coming down, kinetic energy increases and potential energy decreases. Means the conservation of energy will be obeyed, right? So we will calculate individually kinetic energy and potential energy, right? So first, kinetic energy part I will be doing it. Kinetic energy. Just hold on. So kinetic energy part I will do first, then I will go with the potential energy. Kinetic energy. Kinetic energy general formula is what? Half m v square. So kinetic energy is equals to half mv square. Now, so based on that half mv square, if I do kinetic energy, k I am representing, that is what? Half m v square. General formula I have written. Now, so as it is moving horizontally, no? So I am taking horizontal velocity there of m along in this particular direction it is moving, right? So that velocity only I am taking, u cos theta I am taking. So along the velocity along horizontal is u cos theta. So velocity I have written and I will be writing square for this. Okay. Now, so half m u cos theta whole square. Now this u cos theta whole square, if I expand this further, what do we get? Half m u square cos square theta we will be getting, right? Now half m u square cos square theta. So this is what kinetic energy part for the projectile motion. Now same way if we write for potential energy part also. Potential energy. Potential energy. Now, so potential energy part is what? So generally mgh is our potential energy. And let me take u as potential energy, capital U, mg. And what is the height here? Capital H. H maximum we derived it. So the same thing I am taking. And H value we derived in the last class. That is what I will consider here. So mg. H is what? U square sine square theta by 2g we derived. U square sine square theta by 2g we derived, that I have written here. Right? Now, so further, if we go in detail, and so if I simplify this, so what do we get for potential energy? This g will be cancelled out, right? Now, so what else we will get here? Half 1 by 2 I am writing first. U is equals to 1 by 2 m u square sine square theta we will be getting here, right? So this is potential energy part. Now if we write total energy. Total energy. Total energy is what? Sum of potential energy plus kinetic energy we will be writing. So total energy E is equals to kinetic energy plus potential energy. Now, so that implies kinetic energy is what? Half m u square cos square theta plus this is what? Half m u square sine square theta we have, right? Now, so what we can take out common? Half m u square also I am taking common. So what do we get? Half m u square, if I take out common, cos square theta plus sine square theta, or sine square theta plus cos square theta. Anyhow it is addition only. So this, it is a trigonometric identity. Its value is 1. So what we got finally? Half m u square we got as total energy, right? So this is as per conservation of energy. So the total energy remains constant, we say here, right? So this is about energy part of the projectile. So with this, complete projectile motion is completed here. Okay, we'll go with some problematic part. Right now, in this, what is given we will write first. So what are the given values in the problem? First, initial speed is given. That means what? U is given. U is given. What is that? 10 meter per second. And theta is given. How much? Pi by 4. So let me take it as 45 degrees so that it will be easy for you. Next, they are asking directly horizontal range. Okay. Now, if it is on moon, what is the horizontal range also they are asking. And one more information they have given is what? G is equals to 1 by 6 of G. Right. So what is this G? The G is what? The acceleration due to gravity on the surface of Earth. Right. Now, so I'll try to solve it out here itself. I will write formula of it. So what is the formula of R? R formula is, hold on. So R, for R, what we have formula? U square sine 2 theta by G we have, no? So R is equals to U square sine 2 theta by G. Now, so that implies U is what? 10 square sine 2 into 45 degrees by G. G, let me take it as 10 because they have not mentioned it as 9.8. So I can take it as 10 meter per second square. If they mention 9.8, we have to take the 9.8 only. Okay, this 10 and this square, 110 will cancel out. So what is left out? 10 into sine 2 into 45 sine 90, right? So sine 90 degrees value is what? 1. So 10 into 1. So what we got? Range is 10 meters we got. Okay, so range is nothing but horizontal distance only. So we can take it as units of meter. Now, so what else they asked? They asked about what is the acceleration due to gravity changes. That means G if it is changed. That means if we taken it to some surface of moon. So what happens? G value is decreasing by 6 times. Now, what is the range value on? Let me write on the surface of moon so that we can easy to differentiate. Now, on moon. So what is the acceleration due to gravity? Gravity is decreasing by 6 times. What is horizontal range formula? Same. U square sine 2 theta by G. So remaining all they have mentioned it as same. So G is became G moon, right? This is R is on the surface of moon. Now range on the surface of moon is equals to U square sine 2 theta by Gm became G by 6. Now, so denominator it has come. So this 6 will go up. So 6 into, so what will get? U square sine 2 theta by G. Now, already we found this U square sine 2 theta by G value. What we got? If we solve this only, we got 10. So that means 6 into 10 we got, right? So the range on the surface of moon, it is increased by 6 times. That means 60 it became, right? Now 60 meters. So this is about how to solve a problem by using the range formula for a projectile motion, right? Now, if the batsman has to hit a 6, how much is the boundary distance from him? 75 meters it is there. So what is the speed he was striking the ball? 30 meter per second. If he hit with a speed of 30 meter per second with an angle of 30 degrees with the horizontal, will it go 6 or not? So if it has to go 6, how much distance it has to cover? That 75 meters of horizontal distance it has to be covered. So R value is given. Minimum R value is how much? 75 meters it has to travel. So speed is given, right? And angle is given. So acceleration due to gravity G value also it is given. So we will just cross check whether it is whether it will cover or not, right? So first we will try to write given values, then we will check whether we could get a 6 out of that or not. Okay, so what are the given values from it? First we will try to write given values. Okay, now so what are the given values? What is the speed he was striking? Is U is equals to 30 meter per second it is given, right? Now so it is given in the question 30 meter per second. With this much speed the batsman is striking the ball. Next, at what angle is striking with respect to ground, with respect to horizontal? Same 30 degrees. That also they have given 30 only. Next, so G also they have given in the question 10 meter per second square. And what we want it should cover at least 75 meters, then only it will go to 6, right? So same horizontal range formula I will be taking. What is that? U square sine 2 theta by g. Just now I saw the same, I am using the same here now. So u is what? 30 into 30 u square sine 2 into 30 degrees by g is 10 now. So this 10 and this 0 will be cancelled out. So 33 is 90 into, so sine 60, sine 60 value we got, right? Now so 90 into sine 60 value, sine 60 value is root 3 by 2. Okay, now sine 30 is 1 by 2, sine 60 is root 3 by 2. Now, now 90 into, so what we got, r is equals to 90 into root 3 value is 1.732 by 2. So this 2 I will be taking here. 90 by 2 is 45 into 1.732. Now if I do this 90 into 1.732, so obviously I will be getting more than 45 because 1.5 more than 1.5 is there, no? So approximately also we can say it will be more than 45 we will be getting, right? Now so what is this value? 45 into 1.732, if we do, you will be getting exact value, you will get it as a 77.94 meters we will be getting, right? So with that much speed, with the same with the angle of 30 degrees with horizontal, if we hit the ball, so how much distance it will travel? 77.94 meters it will travel. How much distance is there boundary? 75 meters. So will it go 6 or not? Obviously it will go 6. As we know, we have done it with projectile motion. So and it is covering 77.94 meters with this much speed. So boundary is at 75 meters only. So easily it will cover 6, right? So that is what the given problem. So we can analyze some situations also based on this projectile motion. If we hit with this much speed, whether it will go to 6 or not. So it will now it will no more follow the same horizontal line. It will be following this vertical line only, right? Now, so how it will be followed is so now, so it will be following this path. So from here it will cover like this, right? So that is how it will be taking the 6 and this, right? So two problems we solved on projectile motion.